All right, greetings, YouTube. I got the following questions in the night coming from our college algebra course. This comes from our section 1.6, more applications. So we had to do a shift over to Moodle, away from Pearson and over to Moodle. So this comes from our Moodle homework. We'll see how it unfolds. So we're asked to solve this equation. I usually like to start with graph paper. And let's start by getting a copy of the original, right? So we'll start with square root. We have what? 3x plus 10. And then we have equals 5 minus 2x, okay? So we asked to solve this. Okay, so in our lecture, if you either missed the lecture or didn't get a live lecture, keep in mind that I have copies of my full lectures on my YouTube channel, okay? Beautiful Mind. So with something like this, when solving a radical equation, what we want to do is first we isolate the radical, right? So the radical is already isolated for us, so we've already gotten that by itself. So then the next step is that we want to do is we want to so after we isolate the radical, then we want to get rid of the radical by doing the inverse operation. So the inverse of square root is we want to square both sides, all right? Square the entire left-hand side and square the entire right-hand side. When I say on both sides, I mean the left and right side of the equal sign. So whenever you see me draw this vertical bar, that's so I can make a distinction between the left side of the equal sign and the right side. And so if you watch the way I go through these, more often than not, whatever you see me do on the left-hand side of the equal sign, I also do on the right-hand side of the equal sign. Just like in life, where it's ideal to be balanced, this is the exact same thing, okay? So then on the left, when we square both sides, that square, this symbol is canceled by that symbol, right? And so I'm going to bring down my equal sign. So on the left, we're going to be left with 3x plus 10. And then on the right, we need to FOIL. Just come on in. I am doing a recording, just so you know, so just kind of give me a second. Yeah, it's fine. So next we want to FOIL. Let me go ahead and write this out so that you can see it. 5 minus 2x. Again, this squared symbol means multiplied by itself twice. So we're going to say 5 minus 2x, right? So then if we FOIL, so to distribute, basically what we're saying is that each of these two terms in the first binomial needs to be multiplied and added with each of these two terms in the second binomial. So 5 needs to be multiplied by each thing, and this negative 2x needs to be multiplied by each thing, okay? So FOIL, it goes like this. First, outer, inner, last, okay? So let's do that and see what happens. 3x plus 10. First times first, I need a little bit more space. Just bring this down a little bit. I'm not going to lie. I really enjoy doing math on my iPad because, like how if I made a mistake, how I was able to take the image and move it. I don't have to erase. And then even if I do erase, it's clean. It's not like residue or anything. It's pristine. Anyway, shameless plug, for Apple, whatever. Maybe one day I'll make my own device. One day. Okay, but if we say I'm watching the clock, because I do have a class that's about to start. We got like 15 minutes, okay. So if we do first times first, we'll get 25. Outer times outer, 5 times 2 is going to be negative 10x. Inner times inner is also going to be a negative 10x. And last times last is going to be plus 4x squared, right? So at this stage, I'm going to do a couple of steps in one. I'm going to combine like terms, and I'm basically going to I'm going to move everything to one side. So I'm going to set it equal to 0. So in doing that, what I'm going to do, I'm going to subtract 3x from both sides. I'll just put it here. And I'm going to subtract 10 from both sides, and I'll line that up with this, okay? So again, what we did on one side, we did on the other. On the left-hand side, we get 0. That adds to 0, that adds to 0. Let's see. 25 minus 10 is what, 15? Actually, I'm going to rearrange the order. I want to do it in descending power order, so we're going to have this 4x squared. All right, so if we look at the degree 1 terms, we got negative 10 plus negative 10 plus negative 3. So negative 10 plus negative 10 is negative 20, plus a negative 3 is negative 23. Hopefully I hadn't made any mistakes. And then 25 plus a negative 10 is a positive 15. Okay. So then at this stage, let's add some paper. Oops, not there. Yeah, we're good. So at this stage, what we'd like to do, we want to factor, right? Now, before, you might be tempted to say two numbers that multiply to give us 15 and add to give us 23, but in this case, that wouldn't be correct. We're actually looking for two numbers that multiply to give us, what is that, 60? I call this the AC method. So, again, you have to say this times this. So 4 times 15 is what, 60. So we're really looking for two numbers that multiply to give us 60, and then add to give us negative 23, and I actually have a methodical way of finding those numbers, right? So we said two numbers that multiply to give us 60 and add to give us negative 23. Now notice that 60 is what, like 6 times 10? But then 6 is 2 times 3, and 10 is 2 times 5, right? So 60 is 2 times 2 times 3 times 5. So then I'm just going to go down the list until I get to the line that adds up to 23. So the first set of factors, we have 1 and 60, but that adds up to 61, so that's no good. We have 2. If we use this 2, we got 6 times 5 is 30 left over, but that adds up to 32, so that's no good. Okay. Can we do 3? Yeah, we can do 3. If we use this 3 times what's left is 20, right? And that adds up to 23. But we want negative 23, so we're going to say negative 3 and negative 20. These are the two numbers that multiply to give us positive 60 and add to give us negative 23. So then the following is a technique I actually got from students. I call it the box method. Or it was kind of shared to me as the box method. It's for factoring trinomials. Okay, so we're going to do the following. We're going to rewrite this negative 23 using those two numbers that we just found. Okay, let's use, I don't want to use that color. Let's go like this. Okay, so the box method is done in the following manner. The upper left-hand corner is going to be our leading term, so there's going to be 4x squared. The bottom right-hand corner is going to be our constant, which is this 15. And then the other diagonal, we're going to rewrite that blue negative 23x using those two numbers that we just found. So we're going to have this negative 3x and this negative 20x, okay? So then, when we look at the two numbers on top, what do they have in common that we can factor out? Well, when we look, we can factor out an x from the two on top. The two on bottom, I would factor out a negative 5. So that we can factor out a negative 5 from both of those. The two on the left, we can factor out 4x. And the two on the right, I would factor out negative 3. Okay, so the claim is that this line here factors into, what do we get? 4x minus 3 times x minus 5. Okay, let's do a quick, we're going to multiply back really quickly just to make sure that it works, right? So 4x times x is indeed 4x squared, so we're good there. Outer, that would be what, negative 20? That would be negative 3, so they add up to negative 23, so we're good there. And then last times last is a positive 15, so this looks good, okay? I'm going to get a copy of this and just kind of move down to the next page just to have some space. Let's copy. So we're going to stand by this result. I want to kind of keep going right here. Boom. We can go like that. Okay, so then I think in class, we made a statement that when things multiply to give us 0, basically set each one to 0 and solve. So I guess we don't need that anymore. So this is called the zero factor property. So then what should be the case is 4x minus 3 equals 0, or x minus 5 equals 0. Okay, if we solve each one, add 3 and divide by 4, x equals 3 divided by 4. Add 5, let me just move this over just a little bit. If we add 5 to both sides, we're going to get x equals 5. So our claim is that x equals 3 by 4 or 5, but we're actually not done at this point. We actually need to check. We need to check and make sure that these actually work. Because sometimes what happens is we produce what's called the right-wrong answer, right? So what we're going to do, we are going to check this in the context of the original, okay? Let's go paper, get rid of the graph paper for now. And I'm going to open up my trusty, dusty, rusty. Hopefully I don't have anything. Okay, I'm not going to worry about that. Let's actually close all these tabs. Come on. Okay, we're going to open up the calculator. My little device is wanting to be slow, though, for some reason. I probably got to delete a bunch of stuff. Maybe delete old pictures. Come on. Okay. So we have this calculator. Okay. So again, we want to check these results in the context of the original. So I'm going to use my graphing calculator to do this. So let me see. So again, if we look at the original on the right over here, if the left side is equal to the right, then instead of plugging it into two separate equations, what I'm going to do, if we said if these are equal, for these to be true, if this is equal to this, and if we said the left minus the right, if two things are equal and we subtract them from each other, we should get an answer of 0, okay? So I'm going to say the left side minus the right side, plug in each of these answers. In either case, we should get 0, okay? So I'm going to go to my y equals. I'm going to do the square root. 5 minus 2x, close the square root, okay? Then I'm going to say minus, I'm going to do another set of parentheses. We got this 5 minus 2x. Nope, I did not type that in correctly in any way, form, or fashion. So we have the square root of 3x plus 10, right? 3x plus 10. Then we're going to say minus the right-hand side, which is this 5 minus 2x. Okay, that looks better. So then I'm going to quit. To the left of the clear button, I'm going to hit variables. I'm going to go to the right to go to y variables. I'm going to hit number 1 for function and number 1 for y1. Basically, I'm calling on that function that I just typed in. Then I'm going to I'm doing parentheses. It's like saying, basically plugging in these values into the function. And again, we should get 0. Okay, that one's clear. And then when we plug in 5, we should also get 0. We got 10. Let's check 5. That's 15. 25 is 5. 10, 5, negative 5, right? Yeah, so the 5 didn't work, okay? So when we checked it, notice that the 5 didn't work. This one did not work in the context of the original. So again, if we had stopped, we would have gotten that one wrong. So then we said x equals 3 by 4. This one worked, but the other one didn't. Okay. So then that's what I would do there. Again, that 5 is what I like to call the right-wrong answer. Algebraically, it's fine, but sometimes these things produce extraneous solutions. And the extraneous solution comes from this step here. When we square both sides, when we do that power property, it can generate like extraneous solutions, so you always have to check. You have to check. Oh, sorry, totally sleeping. We have to check in the context of the original. So you see where the 3 by 4, A was an option, but that would have led us astray. We had to check. So then I will go with B on that one, okay? And on that note, I have to actually get ready for my class. We're going to end this session here, and from one beautiful mind to another, enjoy the rest of your day. Peace.